All right, so I figure what we'll do is continue on from roughly where we were last time, and I know people who weren't here may not have followed everything. So if we need to backtrack a little bit, we can, since obviously we had problems with the video and we couldn't use the projector.
Is that why the thing was only like 6 minutes? Because I went back to look at the video afterwards, and it was only like on your YouTube channel, the video was only like 6 minutes.
I know, I need to delete that one. Yes and no. Yeah, like what happened was like the projector wasn't working and I didn't know that that's what was wrong. And so I restarted my computer and I tried to reconnect, but it doesn't let you reconnect and continue that same broadcast, I guess. And so that's why, because after trying to get it working, it just rebooting my computer killed that broadcast. So I could have started another one, but we were whiteboarding anyways because the projector didn't work, so nobody could see anything. So you know, if I was going to do that, I would have ended up having to like set my laptop up as like a. Yeah. I mean, I could have done that, I guess. Should have thought about that. So we got up around this setting up attached to lanes area in the last class, right? Where we started talking about how we're going to attach a note to a lane. And then we discussed the different options for it, right? Like we could have the create note also attach something to the lane, or we could have a separate action to do that. And we also discussed where that data could reside, whether or not the lane information was part of the note itself, and so each note knew which lane it was in, or whether the lane knew about the notes in that lane. And we discussed the pros and cons of each approach. And sort of what we came out with was the same as what the book route the book went down, which is that it seems like even though there's some painful parts when the lane knows the notes in the lane, there's some things that are still hard to do, that there are some other items that are almost impossible to do if we have the lane attached to the notes instead, or much harder to do. And so it makes more sense to have the lane know about the notes in the lane versus the note itself knowing the lanes that it's in, right? And I think that's about where we ended up. So yeah, that gets us to this understanding or making lanes responsible of notes section in the book, and then understanding attached to lane. And here there's sort of a couple different models for how to attach to a lane that are shown, right? And both of these are the notion of having a separate action for attaching to a lane. These are just different ways to write this. Is lane actions.attach to lane following the node actions.create. So it's just two entirely separate actions that you're writing, like you do one and you do the other. And the only way that they're connected in this case is the fact that this add note function or method inside of let me make this a little larger, is the fact that this add note method inside of the lane is the one that executes both actions. And that's still the only way they're attached in here. The only difference is in this one, they're completely independent. So node actions.create and lane actions.attach to lane have no association. And in this second version, there's an association between them. And I cannot remember, have we discussed the concept of promises at all in any of the classes that we've had? Does it sound familiar? Yeah. They're pretty complex concepts, so I don't know if we'll talk too much about it, but it's a way for code to run asynchronously and wait for something else to happen before the next thing happens. So if we look at this little bit of code, we won't get into too much detail, but we could also connect the creation of this and the lane, adding it to a lane by using a promise type approach, where what we could do is we could have it so that when we call nodeActions.create, it'll return a promise which says essentially like, when I'm done creating this note, then I'll let you know and you can take another action at that point. And so that's what would be going on if we use this promise type approach. I'm glad we didn't, at least right now, because again, promises are a pretty complex concept. Maybe, since I don't plan on getting all the way through, plan on pretty much just finishing this chapter, and then we'll talk about the next chapter. Maybe we'll spend some time at the end of this class to talk about the concept of promises and introduce it. But I have another concept that we can talk more about before that, which I think is more generally practical. And that's the reduce that was used at the end of this chapter, which I think will be useful to discuss in more detail. So we end up going down the route of just calling the two things separately, where we create the note separately from attaching it to the lane. And at this point, this should begin to feel a little bit rote, right? We're beginning to fall into a pattern. This feels like something that we've done a few times, right? Okay, how do we go ahead and create this action? Well, we need to go into our lane actions and tell it that an action exists. All right, I'm feeling like we know how to do this. And then we need to go into our lane store and have code that handles this action. And we'll come back to this in just a moment. And well, we sort of skip over because then it also adds this detached to lane bit. So I'm going to skip down off this for a moment. And then we need to go down into our lane itself and actually call the action, right? So that we're using it. So those are like the 3 bits of setting this up. Is we need to be able to invoke the action, but first we need to sort of define the action that it exists, and then define what the behavior will be when we take that action. Does that pattern make sense? Feel like something we're pretty comfortable with at this point? So if we're looking at the detach from lane bit of code here, there's a lot of complexity in this little bit of code. Is it clear to people what's going on here? Any confusion? It's not that it's bad code in any way. It's just very dense. So there's a lot that takes place in just a few lines. Again, the style this author really likes, which is just this very, very dense type of code. I think it makes sense. It's it's similar to what we've done before. There's just a little bit of complexity, like, all right, this thing takes a lane ID and a note ID, but it's taking them as an object. You'll notice they mentioned down here, like down here somewhere else. Oh, this is detached from lane, hold on. Attached to lane is the one I wanted to look at. It takes a lane ID and a node ID, and they make a note here somewhere, I think, that we could use positional parameters for this instead of an object. And positional parameters just means your standard, like, one argument, the first argument and the second argument to your function. I don't think there's a right or wrong way to handle that. But this one just expects this lane ID and node ID. It calls this set state. This is part of the alt Flux implementation to set your state values of some kind. And what it's setting is the lanes. And here it's going to change your lanes so that if the lane, essentially it's looking for a lane that has the note ID and it wants to add it to, or it's looking for a lane that matches the lane ID, and then it wants to add the node ID into that lane. But if it already has that node ID, then it doesn't need to add it to it, is what this code's doing. But it's using a lot of the more complex, like a lot of these are, you can begin to see just how powerful some of this stuff is when you're using these sort of methods that iterate over arrays. Because in our first JavaScript class, for example, we wrote all these out, right? Like we wrote out something that was like a map. You got like a for, you know, I equals 0, I is less than like array dot length. You step over it, and then you have your code inside of it. And then we would end up having to have some sort of for loop for this includes to try and step over it and find one that matches. And then this filter would have to be another for loop that we wrote. And well, concat wouldn't, that's different, but you can begin to see how nice it is that we don't have to write those out, like these separate for loops out. We've just got functions that encapsulate that logic for us and step over everything. Does all that make sense? I think that's, and then detach from lane, pretty much the exact same thing, right? We need to be able to attach from the lane, and we're detaching when we delete a note. And the reason we need to detach from lane is because we went with the data model approach where the lane has the notes as an array and the lane isn't part of the note. So if the lane ID was already inside of the note, we wouldn't have to have this separate detach from lane action, because when you delete a note, it would delete the information about its lane. But since we have them as separate, we have to take a separate action to remove it from the lane. But that's pretty much the exact same thing, right? Following our same pattern. All right, we needed to say, here's our action that exists, and now we define what that actually entails, which looks a lot like the add, except, all right, we're gonna give it a lane ID and a node ID. We're gonna look for the lane that matches the lane that we're in, and then we're going to delete the note from that lane and return everything. Has a couple notes here too on these that, like, if you try to attach a note to a lane that doesn't exist, it might be nice to give a warning. So, you know, maybe we'll come back in a minute and add that functionality in, even though I don't know if we probably won't, because the easiest way to test that would be to write tests around it as opposed to have it in your code. And since we haven't done any test-driven development, we won't do that here. But it also mentions, like, for the detach, okay, it would be nice if it doesn't detach something, that it gave some sort of warning, right? And that's what you'd be doing if you were writing real world code, is you're going to add a whole bunch of logic around it to protect you from these edge cases, these problems that can happen. So at this point, we've created these actions that all modifiers store, and then the next simple piece here, right, is we go ahead and import the lane actions into our lane, which means when we call our lane component, we need to pull off this lane actions property, because that lane actions property is going to get passed in down here from this connect. And now we can use those lane actions. When we add a note, one of our steps is attaching it to the lane as well. And when we delete a note, one of our steps is detaching it from the lane. And we'll talk about how we're doing the filtering in just a minute too, but can anybody think of any, I mean, there's pros and cons to the way this works in terms of these being separate actions and only being connected through the UI in this way. So like what are some of the cons in terms of these actions being completely separate, and it's only at this sort of connected UI level that we're making sure that when we create a note, we're also attaching it to a lane? So what if we had a different way to create a note? I don't know. What if there was a different path to create a note somewhere else in the UI, or there was a path. Let's make this more API type driven. So somebody can call an endpoint to create a note, right? Like one thing that you'd have to do, given that they're coupled this sort of loosely here, is if you don't want that note to, if you want that note to be in a lane, you'd have to either duplicate this logic or pull this logic out and share it between the different pieces in some way, right? And that's because these are two completely separate actions. So you have to remember anywhere that you're allowing somebody to add a note, you also have to attach it to a lane. Otherwise, you may get your program into an awkward state. And the same thing for the delete. So that's a trade-off that you're making by having this decoupled approach. Is it's easy to take these independent actions, which is one of the positive aspects of it. If you only need to do one part of this, it's easy to do that. But you have to remember anywhere you need to add a note, you have to take both those types of actions, right? Or anywhere you need to delete a note, you really have to take both those actions, or else you end up in an inconsistent state. So it's just a set of trade-offs for that. So let's talk about this last bit. The last little bit that we have in this that's new is we've got our, if you remember what we had last time, is there was a problem where any task that we added, like any new note that we added, showed up in every one of our lanes. And that was sort of at the end of class last time, where we added in the support for adding a note, and we've added in support for lanes, but the lanes didn't know what notes were connected to that lane. So there was no association between a lane and notes. So they just rendered all of the notes in every lane, right? And so in order to not render all of the notes in every lane, because now we've just added support for when we create a note, attach it to a lane, delete it from a lane, etc., we need a way to filter the notes for each lane. So since this is a single lane, and we want to pass notes into this notes component rendering for this lane, we need to say what notes do we actually care about, and that's why we have select notes by IDs. So what we're passing into this guy is just all of the notes that we have, and then this array of notes that are actually in our lane, which this isn't actually notes, this is just the ID of the notes, not the full note. And then select notes by IDs is going to iterate over all of the notes, check for ones that are in this list of node IDs, and add them to what we return. And so this is where I wanted to spend a little bit more time, because I don't think we've actually encountered reduce before either, have we? Does anybody remember if we've encountered reduce before? All right, so has anyone here ever heard, ever looked into early, I don't know if they still use this same approach, but has anyone here ever read at all about how Google's algorithm works for computing all of the sites and the site ranking and everything so that it can give you results so quickly?
Stores it somewhere.
It stores it somewhere, but what they're storing is a whole bunch of different rankings of sites and references that say like, oh, this site is referenced by these other sites, and so that helps increase its ranking. It's going to have a higher ranking because other sites that we rank high also refer to that site. And so at a very basic level, right? If you have a site like, I don't know, what's a good trustworthy site? You know, like you have, I don't know, National Geographic or something, and that has references to other sites. Well, the fact that it links back to these other sites sort of increases the reputation of those other sites because, oh, National Geographic has a good reputation for stuff. And then that's sort of, it ends up being this sort of self-reinforcing thing. So when sites with high trust rankings link to other sites, that helps raise their trust ranking. And if sites with low trust rankings link to sites, that lowers their ranking a little bit too. But in order to do that computation, which is this complex, very complex computation, because it's this many-to-many relationship of sites, one of the things that they're doing on the back end, at least early on, was they ran a tool called MapReduce to do a lot of that logic. So if we look at our code that we've got here for this stuff, we can see map. And now we've just sort of introduced for the first time reduce. And so not to reduce it, their stuff simpler than it actually is, but the core of the map reduce infrastructure that Google uses for that stuff is sort of just the same type of logic. The only difference is they do it distributed. Because of the way map and reduce work, you can spread that out across hundreds or thousands of computers very efficiently. But it's the same, in a sense, it's these same functions that are running, this map and this reduce type function. So let's take a minute and talk about what reduce is doing. Like they put a note here, like reduce is a powerful method that allows us to fold data. Does that make sense to anyone? Fold data? No? Yeah. You can implement filter and map through it. Here we are using it to concatenate notes matching to the IDs. I think you get a little bit better explanation over here from Mozilla Developer Networks, where they say the reduce method applies a function. It's also complex wording, but applies a function against an accumulator and each element in the array from left to right to reduce it to a single value. So let's look at what they have here, for example, which is very simple. And then we'll do a few other examples to sort of get the feel for what reduce is actually doing. But here we've got an array, 1, 2, 3, 4. And we're going to create a function. And our function has an accumulator and then the current value. And what that function is going to return every time it runs is accumulator plus current value. And then if we look here at, we run this. So we call array1, which is just this array dot reduce, telling it here's our function that we're using to reduce. And we expect to get 10 out. And so what's actually happening in the code is it's stepping over each value in the array, just like any of our other sort of iterative array methods. So the first step, the current value is going to be 1. And our accumulator, well, we didn't define a default state for the accumulator here, so I think it's 0, but you can do that as well. So let's assume that the accumulator is 0, so 0 plus 1 is just 1. And then it runs through this function a second time, but now the accumulator is the new value. Each time it returns that value back in here and feeds it in as the accumulator value. So now the accumulator value is 1, and our current value is going to be 2. So now 1 plus 2 is 3. We run through one more time. And now our accumulator value is 3. The current value is 3, so we get 6. And then 6 plus 4 is 10. So it's literally just iterating over. It's reduce. It's reducing all of the inputs of an array down to one value that you get out instead of an array that you get out,
Yeah,
right?
because map turns one array into another array.
Map turns one array into another array, and reduce shrinks it down. Yep. So if we were, for anybody watching on, I'll do it this way so it's a little easier for other people to see. But yeah, if you're doing a map and you have X, Y, Z as your input array, and you're mapping it, then what you get out on the other side is X prime, prime, Y prime, and Z prime. So you get back another array. It's the same length as your original one, but you've done some sort of transformation against each value in it. Whereas reduce is the same type of thing. You put X, Y, and Z in, and what you'll get out is A, right? You get back an entirely different value, but one value instead of an array that exactly matches your original array. And so between these two, map and reduce functions, pretty much every other one of those. So if we looked at an array real fast for JavaScript. Okay, fine. That's weird. Let's reload this whole thing. Is it gonna work now? Maybe not. All right, so if you look at an array, and this isn't as nicely formatted as the other one, but there's a lot of functions on here that are iterative type functions that give you back something like, wow, this documentation must be broken right now. All right, let me see if I can just move straight over to MDN, how it worked that way. All right. I think this will work. They've changed their documentation a lot. So if we were to look at a lot of these iteration methods over an array, and even some of those other ones, like array.prototype.entries returns a new array iterator object that contains the key value pairs for each index in the array. So that could be done with map. That's just a little bit of syntactic sugar on top of map. Array.prototype.every returns true if every element in this array satisfies the provided testing function, right? So that returns a single value. So we could implement that with reduce. It's just a little bit of sugar around reduce, right? Array.prototype.filter creates a new array with all the elements of this array for which the provided filtering function returns true. This is a little confusing. Like, oh, okay, that doesn't map directly to map or reduce. It's not map because some items may be missing. And it's not reduce because you get back a new array, not one value. But you could say that that new array is your one value that you get back. You've just manipulated it in some way. And I'll come back to that in a moment. Because that's exactly what we were doing in the tutorial. Array.prototype.find returns the found value in the array if an element in the array satisfies the provided testing function, or undefined if not found. So that could be reduce. You could reduce your whole array to say, all right, this thing matches what I was looking for as my starting thing, and so return that value, otherwise I'm going to return undefined. So most of these, almost all of these, almost every one of those could be rewritten as map reduce. So those are sort of these fundamental building blocks of working with. So it's really, really useful to learn map reduce and learn how to use these two different functions to accomplish a lot of these tasks. That's the type of thing that will translate to any programming language that you work in, and translate just about anywhere that you sort of work on data. It's very, very common set of patterns. So let's look at how we're using reduce here, because this gets back to what I was talking about, that sort of filter and giving back an array method instead. So what we do in this select notes by IDs, and again, I could, this is in the lane here. We can break this down in the code if we want to rewrite it, but let's pull this out real fast. Just because, again, this is the way I like to do a lot of this stuff, because it makes more sense to me when I break stuff down. So if I say const reduce function equals, and then I'm just going to assign it that value, and this is going to be my reduce function. So now we can see that this reduce, all it's doing is taking a reducer function and this second argument. And we didn't see that second argument in our example over here of reduce, at least at first. Yeah, I got some problems going on there. I don't know what happened. Anyways, that second argument is the starting value for your accumulator. So I can give you a good example of what that means. If we pull up developer tools here, for example, and let's create our simple array. 1, 2, 3, 4, right? And we've already done this before. Nums.reduce. We're just going to inline this function. Sum number, the current number, and all this is going to return is sum plus num. And I'm going to assign this to sum at the top level, and sum is 10, right? Because we already did that. But if we change this and we give it a starting value as the second argument for reduce, so what do we want to start with? Let's start with 10. And our total is 20, because that's the initial value that it uses for the accumulator the first time it runs through it. So it starts with 10 instead of the 0 that was sort of implicit.
Gotcha. And it adds on accordingly.
And then it steps through every time and adds on, right? So that's all that second argument is the initial value for your accumulator. So if we step back over and look at our code, we can see our initial value for our accumulator here is an empty array, right? Which tells us something about what we're expecting to get out. We're not expecting to get a number out. We're not expecting to get a string out. We're expecting to get an array out. And so this is where we're doing something a little different, right? We're still getting one value out with reduce. It just happens to be an array instead of something else. You'll notice even up here, right? Since we're returning an array now, and I said reduce returns one value, in this little note it says you can implement filter and map through reduce. So I'm going to take a moment after we walk through this and show you like how you would implement map using reduce as well, just to show you that really all of this could be reduced to this sort of reduce function. But it's still nice to not have to do that, right? It's another piece of syntactic sugar stacked up on top of the other ones to make all this easy.
Also use map and reduce with it each, like replace all maps and reduces with each, is like each function.
Yeah, you could. Yeah, for each is more generic. Definitely, in terms of it just iterates over. It doesn't tell you what you're getting back. And in fact, one of the challenges with replacing them with a for each is for each itself, unlike map and reduce, I believe. Let me double check this. Look, I have to actually go to the real documentation site. Go over here. I'm gonna verify this real fast, but I'm pretty sure for each doesn't return a value. So if you were to use for each instead of map or reduce or one of those, what you end up having to do that's different is you have to have an external variable that you're manipulating. Whereas map and reduce are pure functions in the sense that, or can be in the sense that they don't have to manipulate anything outside of themselves, because when you're done with it, it just returns a value of some kind and then you can work with that, which means that it's a little cleaner code to use map and reduce versus for each a lot of times. Now, some cases you end up needing to use for each for some reason. I need to manipulate a few external values, but map and reduce can be cleaner in the sense that they don't have to have an external variable. For each would if you want to get something back out of it. So if we've rewritten this, now we've got our reduce function, we've got our empty array, breaking this down. So what our reduce function is going to do is notes, that's just our accumulator, right? And then ID, well, that's going to be, in this case, we're stepping over node IDs, and node IDs, if we go back up here, were all of the notes that are in this lane based off their ID. So we're going to pass in each ID for the lane. And then what it's going to do is look at all of our notes or look at the notes that we passed in. That's this array that started with nothing, right? And concatenate onto it the actual note, but it's only going to concatenate it onto it if that note, when we look through all of the notes, if the note ID through all the notes matches the ID that we passed in. So it's a little confusing here. So what this will do is for each one of these IDs in our lane, it's going to call this reduce function. And then that's going to find that note, the actual note in all notes, because remember, all we had was an ID, not the whole note object. It's going to find it from all notes by using this filter and then concatenate it onto our new notes array. And that notes array is what we're going to return here so that this lane only has the notes that belong in that lane. Does that make sense? Yeah. So this is some, these are some really powerful types of functions that let you do all sorts of, I mean, I don't even know how to describe this in a way that it sounds simple, like you look at it and it maybe looks simple at first, but you can do some really, really powerful logic using this sort of math reduce type behavior in a lot of different ways. And as I said before, let's go ahead and I cannot, on a Mac, I can never remember the shortcut for developer tools. So let's take a moment real fast and try and see if we can implement map or a map-like function using this just reduce, which I think we can do very easily because it's almost the same thing that we have written over there, right? So if we wanted to create map, so let's create a function called map. And what this is going to be is, this may be a little hard. Let me think about this for a second. How can I write this at a top level like this? Is that going to work very easily? We're going to write it a little different than the normal map because normally map is like a method on the array, but because I'm writing this separately, it'll just take in the array as one of its arguments. So map is going to be a function. It's going to take 3 arguments. It's going to take the array or function. And does it need anything else? Like, what do we need to pass into map? Map just needs your function, right? And potentially a initial value, right? The map just needs the array that we're bringing in, this function, and whatever our function is that we want to apply, and an initial value. Except, I don't know if we need an initial value. We'll see. We don't for map, yeah. See it? I'm doing this on the fly. You guys are going to see me make some mistakes. If we have that, now we're going to be very similar to what we had over here, right? We've got our array, and we want to reduce it. We're going to assume it has this reduce method. And this is going to use our function, in a sense, and it's going to take as its initial value for this, an array of some kind. Except the problem here is we can't just pass our function directly into reduce, because reduce behaves differently than map. They expect different types of functions. So what map expects is a function that only takes in the current index or the current value. It takes some other stuff, so we're not going to implement all of it, but it takes in the value of your current item. It doesn't take in an accumulator in your current item. Whereas what reduce expects for its function is an accumulator and your current item. So we have to here create our function that reduce is going to take, and that's our accumulator and our current item or whatever in our array. So this is our function for reduce. I'm probably going to make some mistakes here because we're trying to live code this. But it takes in our accumulator and our current item. And then what this is going to need to do is do accumulator.concat. So we're adding on to it because in this case, since we're doing this, we want this to be a map. We're converting each one of these items one by one into a new array. So we're just creating this new array. And what we're going to concat onto that array is the function that we passed into our map, given the item that we're trying to apply that function on this time around. So that's what we're concatenating in. And then our second argument to reduce needs to be our empty array, because that's our initialization for this guy. And then we need to, at the end of this, oops, I'm gonna go up here. I need to return the result of running this. And then I think this is going to work. Anybody see anything wrong with it? It might be. And this should also make you feel better about your code. If you realize that I've been coding for a very long time, and this is a 4-line function that I just wrote. And you guys can all read this right now, and I'm going, I think this works. I'm not certain, right? So let's give this a try. We want to map, let's map 1, 2, and 3. And then for our function, let's take in a number and return, let's square it. I forgot a parenthesis somewhere. Cannot read property concat of undefined. So what am I missing here? All right. This maps correctly to the end of that. Reduce does take a, let's make sure I've got the signature right. Reduce. Reduce takes your reducer function and your starting value. Yep. And your reducer function takes your accumulator and your current value. Yep.
We need a line before the return, like at the very beginning, say accumulator equals empty array.
No, that's what this is intended to be, is this initialization for the accumulator. So this should be sort of initializing it. To an empty array. assuming I have this all written right. So this ends there. Oh. Well, one problem I have, I don't know if this is the issue. Yeah, it probably is at least part of it. I need this to return. I have it written this way. Let's try this. There we go. Because I used brackets instead of just being a straight line. If you don't have brackets around it, it automatically returns the value. That's what I'm doing here. But if you use brackets, you have to explicitly give a return value for fat arrow functions. So there we go. We implemented math off of reduce, right? And it's pretty simple. Well, I say simple, but I mean, there's a lot of code, a lot of complexity going on in there. And so, yeah, it's not something I expected to look at and go like, oh yeah, I'd be able to rewrite that myself without somebody else helping me out. But it's a good thing to practice, to try to implement some of these functions. Like, oh, I'm going to rewrite this function this other way to see if I can make it work. Are we all good there? I think so. So the last step that we did in this chapter, and this is just really simple, is we extract lane header from lane, right? So this isn't even something that's really required for us to do. The only reason this was done was to try and keep the components simpler, and so that they're just not as complex. It's something that when you're working on a React app or something like that, you'll sort of get a feel as you're working through things like, oh, I could probably extract this into a component so that this other one is simpler and easier to work with and easier for somebody to look at. This is purely, at least right now, there might be a value for this in the next chapter, and actually we do get a tiny bit of value, but right now at least, extracting lane header is purely for the sake of people working with the code. It's not for the sake of like, we have to do this or it's actually functionally better. It's just, it's easier to look at smaller pieces of code and figure out what they're doing than larger pieces of code. So by extracting lane header, all we're doing is making it easier to work with. So I assume for the people who have gone through this part was easy, right? Because this is literally just taking a piece of our lane, moving it into another file and referring to it. Are there any questions around that at all? Any thoughts or concerns with that? No? Okay. So I'm going to give you guys the choice here. We've got, I don't know, about 40 minutes or so left. Would you rather start talking about this editing lanes chapter? And I know that at least in this class, people are already there or partway there, so we can start digging into this a little more. Or if you'd rather learn another new concept or another concept that we didn't even really cover in the book, we could take a little bit of time and talk about the idea of promises. Now recognize this will be a pretty complex concept. It's probably not going to click completely, but it was in the book real fast. And so we could talk a little bit about what promises are and how they allow for asynchronous style coding. Or we can dive more into this chapter on editing lanes. Any preferences? Or something else. If you want to review some of this other stuff, you want to talk about reduce more, have it make more sense, talk about map reduce more, give some other examples of that, hands-on examples, we can work through some more of that. If it's going to make more sense if we work through some more examples of those.
We should stay away from promises.
Stay away from promises?
Don't want to get too confused.
I mean, I think it's a valid point. Promises are a pretty complex concept. And since I don't think we ever actually implement, I'll have to double check the implementing drag and drop promises, then we probably don't need to go there. We could also just finish a little early if people would prefer that. I mean, recognize we got started really late, so it's a short day. We did that, but that's okay too. Obviously, it's a small class today. So
This is something extra I did. Thought having one CSS file was kind of annoying, like one long file, so I just split it up into many files and just imported them into the main CSS file.
right. There's several different ways to do that, and I actually don't know if this supports it. Let's try something out here. So I think that's a fun thing to work with. So I'm going to change my branch here. I'm not in edit lanes. Come on, are you going to work with me? Okay. That's fun. All right. So let me check and see how our CSS is being referenced right now in our application, because we've got main.css, right? And this is, where is it being loaded? Is my question. I haven't looked for this. It's not finding it. All right. So I'm guessing it's part of our, or getting built right into our index file or something, sort of automatically. Let's see here. Style.css. Okay, it's getting built out. So let me go to my index here. Is this importing it? It's not. So technically, I'm going to check this. What was the question? He was just saying that he has doesn't like all the CSS sitting in one file. Like this main.css is getting large and complicated, and so instead he broke it out into separate files and imported them in here, which you can do. You can do using just CSS and the CSS version of things, where we could create at this level where our main.css is or something, we can make another file, a new file, say note.css, and then all these little bits of note logic, note editable, note delete, note value. Let me see if there's any more here that we need. Note hover, dot note. We could take all that out and move it into our notes.css file instead. And so if we're in the node.css file now, and we move that out, then what is it? Is it just import?
Add import node.css.
Right. So this is sort of the straight CSS way. Is it with a semicolon? I can't remember. I think it is. This is the straight CSS way to split your CSS files up. And what I think you'll notice, if we actually even looked at the index, we probably still only have build one CSS file. So when it outputs it, it's only one file that we're working with. But when you're working with it, you have separate CSS files to work off of, so that, oh, now I don't have everything in one place. I know where my note styling is, and it's easy to work with. Now, I don't know if this project is going to support what I'm going to do here, so we'll see. Right, return this to the state it was in. Whoops. That's good. I don't know if this is going to support the way I'm going to split this up, but we're going to find out. Another way to do this in a lot of modern JavaScript applications, especially ones using Webpack, is to couple this a little differently. You can use a Webpack. So Webpack is the tool we're using to build our code to turn it into something that can run in the browser, because we're writing ES6 compatible JavaScript, which a lot of browsers can't run all those features. And in order for the browser to be able to run this code, we need something to build it to browser compatible code. That's what Webpack is doing for us. So if we go over here and we actually look at this build output, like app.js, we're going to see a whole bunch of just sort of gibberish content here. But this is what's actually being run in the browser instead of what we had. And then we have this map file, which tells it how to map back to our original versions of our files so that when you're in the browser, you can still debug the original file. So another thing that Webpack can do is it can package up not just your JavaScript, but it can also package up all of your dependencies if you use it that way, if you've enabled the plugins to support that. So if instead of having sort of this main.css imported however it's being built in, maybe it's the Webpack config is doing something with it, I'm not sure. Yeah, I think our Webpack config isn't going to support this. We'd have to add in some code for something, I bet. We'll see. Styles. Yep, I'm gonna take a stab at it, but I don't think it's gonna support it right off the bat. But you could instead, let's see here. Get rid of that. Let's go up to this app file. A common pattern in a lot of these modern JavaScript apps is to do like import at the right level, I think it is. Import main.css. And this will import that CSS file. And so if you wanted to split some things out in a different way, like I don't want this CSS file to have to know about the other ones because it's just concerned with the main bits. And maybe I go up here into my note. And I don't know if this is going to work again. And I say import note.css. Yeah, this is it telling me, I don't know how to do this import. So this stuff isn't enabled in our version of Webpack. We have to add some additional plugins. But this is a common pattern in workflow where now what's going on is now when I go in this note file, I get a feel for everything about a note, but I don't have to have this very loose coupling from CSS to note. It's much tighter because, oh, this note file tells me, here's my CSS. I know exactly where to go for my CSS for a note. Yeah, it doesn't fix the problems that CSS has where different styles can stomp on each other and cause issues, but it makes it a lot easier to construct your app in terms of pieces that at least appear self-contained. So that's another way to do that. But yeah, looks like this doesn't support the notion of having it that way. So instead, you would have to do it like we did here, import note.css instead. And I don't know why my app here didn't blow up. But now we should build successfully and be back. So that's another, I mean, there's a lot of, recognize this tutorial isn't trying to go over how to do all these different steps in terms of building an app that you would actually build on a team, because you would definitely split things up like that. Or ideally you would. I mean, don't get me wrong, there's places where you're gonna go there and there's gonna be one CSS file for the whole project and it's gonna be frustrating when you work with it. But that's the lessons to be learned about how to engineer things. That's the engineering part of software engineering. It's not how to code. It's not how to write bits of code. It's not how to do CSS. The engineering part is how do you make this stuff scalable and maintainable, and how do you work on a team and make it so that everyone can be effective when they're working on it. So I mean, that's a good one too, splitting stuff up like that. I like that.
Because we added the new CSS just for lanes, so I made a notes.css, a lanes.css.
Right.
And I added some settings CSS stuff.
Yep. Yeah, I mean, all that's great because it helps you find the CSS, it helps you keep it separate, think about it in separate ways. And there's other layers on top of that too, because CSS is a very, very primitive tool, right? It doesn't give you very complex functionality. They're trying to add it in, but it's going to take forever. So for example, a very popular layer on top of it is something called Sass. Maybe this is why I wasn't working before. Hangouts. We'll see. But Sass is a popular layer on top of it. So Sass gives some additional capabilities on top of CSS that allow you to build things out more easily. And that includes variables. So CSS doesn't really have a good capability to have variables like tell it, here's my primary color. We use that color in multiple places throughout the code, right? In my CSS. So you're used to, oh, if I need to say primary color in CSS by itself, I'm usually writing out the same hexadecimal value in multiple places. And now if I want to change that color for different reasons, it's a pain in the butt. I have to go change it in multiple places. A great example of this is the styling work that we did, right? This let's allow the app to be styled, and we have different themes. Well, it would be very easy to set theme color here for, oh, the primary color for this theme is that, the secondary color is this. And if we had to put that in a lot of different places in our application for that theme to apply, it'd be really easy to use it through here and then change what, oh, we didn't really like that as the dark theme. We want to change that a little bit. You don't have to touch all the places. You only have to touch it in one place. So things like Sass or Less is another popular one, are just layers on top of CSS that let you do some really powerful things as well. If you
lets you use like arrays and stuff.
Let you use arrays, let you do nesting. So if you've written complex CSS selectors like nav, you know, if you're writing CSS and you've written CSS for any period of time at all, you've written some sort of complex CSS selector over and over, like dot note, dot completed, you know, div or something. And then you also down here have like dot note, dot active, you know, or something. And something like Sass, those types of things instead allow you to not be quite as repetitive. So you can say dot note, and then inside of here you can say like dot completed. So here's the stuff for like for completed div if you want it to be that. And then you can have a separate one that's like dot active, but they'll both still be wrapped by the dot note. So that only applies to dot note stuff. So it's a really nice, like those different tools give you a lot of nice layers on top of CSS to just make it much easier to work with and read. If you're ever building something out that's any sort of large app or needs a lot of styling, I really recommend using a layer like that as opposed to raw CSS. I don't know if we really have enough time to dive into any of the other topics. I think this next chapter, editing lanes, is a pretty short chapter. So we're gonna get through all of it in the next class. I have no doubt about that. And then we probably, and I recommend if you haven't gotten there, start looking at this implementing. This I expect to be a more complex chapter. So my plan is try and get through editing lanes next class, and then try and do a short demo example project of drag and drop outside of our project to just show you how this drag and drop functionality can be hooked up to any sort of React components. That way, you know, we can think about it independently, and then the class after that to talk about this chapter and how we're actually hooking it up to our notes. And at that point, we'll be, done with the book. And if we want to, if people are interested, we could take an extra class period or something to talk about, like, if we wanted to do test-driven development, how would we have done some of this differently? But I'll just do a poll at that point to see if people are interested in a tiny bit more. Other than that, we're done for today. Anybody watching? I'm going to stop now. But work on the editing lanes and React drag and drop, and we're almost done. We just got a couple more chapters left, so let's push through to completion.